Before calculators, before computers, before the equations that send rockets to Mars, there was a book, written in ink on parchment, in a city where knowledge was currency, and in it a scholar gave the world a new way to think. His name was Muhammad ibn Musa al-Khwarizmi, and though you've likely never said it aloud, you've used his legacy every single day. From the word algorithm that powers your phone to algebra, the language of modern science, his fingerprints are everywhere. So how did a 9th century scholar in Baghdad change the way humanity solves problems? And why does his work still echo through every classroom, lab, and line of code today? Let's turn back the clock to the house of wisdom, to the desert, to the birth of algebra. Baghdad 820 CE, a city of 1 million, capital of the Abbasid Caliphate, and the beating heart of what historians now call the Islamic Golden Age. Under Caliph al-Ma'mun, knowledge wasn't just preserved, it was sought, paid for, debated. Greek philosophy, Indian mathematics, Persian astronomy, Syriac medicine, Chinese engineering, all flowed into Baghdad's libraries. Scholars from across the known world gathered in courtyards and reading halls, translating, arguing, copying, refining. It was an intellectual ecosystem unlike anything the world had ever seen. And into this crucible stepped a scholar from Khwarizm, a region south of the Aral Sea, near the ancient Silk Road, Muhammad ibn Musa al-Khwarizmi. We know surprisingly little about his personal life. No diaries survive, no childhood stories, no letters to friends. But his works, they reshaped civilization. He wasn't a mystic, he wasn't a poet, he was a problem solver, a mathematician, an astronomer, a geographer. And at the House of Wisdom, he was tasked with a very practical mission: make math usable. Before al-Khwarizmi, mathematics was fragmented. The Babylonians solved equations, but only case by case, memorizing templates without general rules. The Greeks mastered geometry, but treated numbers as lengths and areas, avoiding abstraction. The Indians had developed a brilliant place value system, including a concept for zero, but their mathematical text hadn't yet crossed into the Mediterranean world in a systematic way. Merchants needed to divide profits, judges needed to split inheritances, surveyors needed to measure irregular plots of land, astronomers needed to predict planetary motion. Everyone needed calculation, but there was no unified method, no shared language, no step-by-step system that could be taught, tested, and trusted. Al-Khwarizmi's genius was synthesis. He didn't just collect knowledge, he organized it, systematized it, made it teachable. He stripped away the mystique. He built a framework, and that framework would soon get a name that would outlive empires. Around 820 CE, al-Khwarizmi completed a short book. In English, we call it the Compendious Book on Calculation by Completion and Balancing. Its Arabic title gives us our word, algebra. Al-Jab means restoration. Al-Muqabala means balancing. Together, they describe a process, moving terms across a boundary to restore equilibrium. Sounds familiar? It should. It's the foundation of every algebra class taught today. But al-Khwarizmi didn't use symbols. No x, no plus, no equals. He wrote in full sentences, rhetorical algebra. And he proved his methods using geometry. For him, math wasn't abstract. It was visual, practical, rooted in reality. Take his most famous example: a square and 10 roots equal 39. In modern notation, we'd write it as x squared plus 10x equals 39. His solution? Divide the roots in half. Half of 10 is 5. Square it, 25. Add it to 39, 64. Take the square root, 8. Subtract the half you took earlier, 5. 8 minus 5 is 3. The unknown value, 3. This is completing the square, a method still taught worldwide, still used in physics, engineering, economics, still the bridge between arithmetic and higher mathematics. But al-Khwarizmi didn't just solve one equation, he classified them, 6 standard forms, linear and quadratic, each with its own step-by-step procedure. He didn't guess, he proved. He drew geometric shapes to show why the steps worked. He showed that cutting, moving, and rearranging areas preserved equality. He built intuition out of logic. And he didn't stop at theory. He included word problems, real ones, how to divide an estate among heirs according to Islamic law, how to calculate fair shares in trade partnerships, how to measure land after floods changed boundaries, how to weigh goods, convert currencies, plan irrigation channels. Algebra, as he conceived it, wasn't a theoretical exercise. It was a tool for justice, for commerce, for engineering, a universal method for restoring balance to messy, human problems. And yet, the word algebra only entered European languages centuries later, because knowledge, like water, follows the path of least resistance, and in the Middle Ages, that path ran through translation. For 3 centuries, al-Khwarizmi's work remained largely within the Islamic world. It was copied in Damascus, taught in Cairo, studied in Cordoba, referenced in Samarkand. But Europe was still calculating with Roman numerals, still doing arithmetic on wax tablets, still treating math as a trade skill, not a discipline. Then, in the 12th century, Europe woke up. In Toledo, after the Christian reconquest, scholars found libraries filled with Arabic manuscripts, Greek texts lost to the West, Indian mathematical treatises, Persian astronomical tables, and at the center of it all, al-Khwarizmi's works. They began translating. Robert of Chester rendered al-Khwarizmi's algebra into Latin in 1145. A decade later, Gerard of Cremona translated more. His name, Latinized as algorithmy, became shorthand for his arithmetic methods. And from that Latinization, we get the word algorithm. Not from a machine, not from Silicon Valley, from a 9th century Persian scholar who taught people how to solve problems step by step. But translation wasn't enough. Adoption took a champion. Enter Leonardo of Pisa, better known as Fibonacci. After studying in North Africa, Fibonacci returned to Italy and wrote Liber Abaci in 1202, the Book of Calculation. He credited al-Khwarizmi explicitly. He demonstrated the power of Hindu-Arabic numerals. He showed merchants how to multiply large numbers, how to use fractions, how to apply algebraic reasoning to commerce. And slowly, painfully, Europe began to change. Roman numerals couldn't handle complex calculation. Try dividing MCCC XLVI by XXXI. It's exhausting. The new system? Clean, efficient, scalable, with place value, with zero, with algebraic structure. Trade expanded. Banking emerged. Navigation improved. Astronomy advanced. Engineering transformed. The Renaissance didn't begin with paint on canvas. It began with paper, with calculation, with al-Khwarizmi's methods. But here's what's often missed. Al-Khwarizmi didn't just give Europe better math, he gave it a new way of thinking, a mindset, that problems could be broken down, standardized, solved systematically, that knowledge could be shared, verified, and built upon, that uncertainty could be tamed through structure. Today, we don't write equations in paragraphs. We use symbols. We have calculators. We have supercomputers. But the logic, the structure, the belief that any problem can be modeled, balanced, and solved, that's al-Khwarizmi's inheritance. Algebra is no longer just about X and Y. It's the language of physics, of economics, of cryptography, of machine learning. Every time a self-driving car calculates a trajectory, every time a climate model simulates atmospheric flow, every time your phone encrypts a message, every time a hospital schedules staff,
Every time a satellite adjusts its orbit, algebra is working in the background. Al-Khwarizmi didn't invent algebra from nothing. Human beings have been solving for unknowns since ancient Sumer, but he was the first to treat algebra as an independent discipline, with rules, with proofs, with pedagogy, with reproducibility. That's what makes him foundational. He turned problem-solving into a science. And algorithm? It's no longer just a math term. It's the architecture of the digital age. Search engines, social feeds, recommendation systems, autonomous vehicles, medical diagnostics, financial trading, all built on step-by-step procedures, all tracing their conceptual lineage back to a scholar who believed clarity could tame complexity. Today, we live in a world of algorithms, but we forget they began as human attempts to restore balance, to complete what was broken, to make the unknown known.
Al-Khwarizmi never saw a classroom like this, never knew the word computer, never imagined his methods would one day power artificial intelligence, but he understood something timeless, that math isn't just about numbers, it's about structure, about fairness, about giving people tools to think clearly. Every time you balance a budget, every time you solve for an unknown, every time you follow a recipe, a manual, a set of instructions, you're participating in a tradition he helped formalize, a tradition that began in Baghdad, that traveled through empires, that crossed oceans and centuries, that now lives in your hands. His legacy isn't locked in museums. It's alive in every equation, every algorithm, every mind that dares to ask, what if I break this down? What if I restore balance? The next time you hear algebra or algorithm, remember, they're not just words, they're invitations to think, to solve, to build, and to keep the balance. In memory of the scholars who turned curiosity into civilization, thank you for listening.